Good morning, students. In this session, I am going to work out some problems in which I am going to prove certain results using the compound angle formula. So, you are familiar with the formula cos of A plus B, cos of A minus B, sin of A plus B, sin of A minus B, as well as tan A plus B, tan of A minus B. So, in this one we have worked out some problems where we have evaluated or we have simplified or we have proved some result. In the previous session also I had worked out some problems where we had proved some certain results. So, in today's class also, today's session also I am doing the same thing. So, this is the problem: cos of 120 plus A plus cos of 120 minus A is equal to minus cos A. This is what you have to prove. Now, look at the left hand side. It is of the form cos of A plus B. And this is of the form cos of A minus B. 120 is a known angle and A is an unknown quantity. Observe right hand side, we don't have any angle, it's a general angle A we have to get here. So, as usual, we start from the left hand side. Now, let us use the formula cos of A plus B. What is cos of A plus B equal to? It is cos A into cos B minus sin A into sin B. Let me write that one. Cos A means cos 120 degrees into cos B. Cos B means it is cos A here, minus sin A into sin B. Sin 120 into sin A. Now, first one is over. In between we are having positive sign, directly we can write. Suppose we had a negative sign, we should have written the terms inside the bracket because both the terms should be multiplied by the minus sign. So, when you have minus sign, be careful when there are more terms, no, make it a habit to write inside the another bracket. Now, write the next one. It is of the form cos of A minus B. That means that cos A into cos B plus sin A into sin B. Sin A into sin B. So, first one was cos of A plus B. So, it was cos A into cos B minus sin A into sin B. Second one was cos of A minus B. So, cos A cos B plus sin A sin B. First, after writing the expansion, you just see if you could do cancellation of some terms. Look here, minus sin 120 into sin A, there it is plus 120 into sin A. Plus sin of 120 into sin A. One is positive, the other is negative. Immediately you do the cancellation. Look at the other two terms. Cos 120 into cos A plus cos 120 into cos A. That means that there are two terms here. So, 1 plus 1 is equal to 2. So, I can write 2 times cos of 120 degrees into cos A. Now, see cos 120, now here I have used the compound angle formula. Now I am going to use the allied angle rule that you have learnt in the earlier sessions. In the first PU itself you have learnt cos of 120. You can write that in two different ways. One is 90 plus 30. The other one 180 minus 60, both are correct. If you write 90 plus 30, you see that cos would be changed over to sin, its co-function. Suppose you write 180 minus something, then the same trigonometry function remains. But here 120 angle being in the second quadrant, cos ratio will be negative. So, let me write this as 2 times cos of 180 minus 60 into cos A. Now, this is equal to 2 into here 180 minus theta, that is minus cos theta, right, minus cos of 60 degrees into cos A. Now, because minus sign I am getting, I am writing the bracket, otherwise this minus sign should be written here. So, let me write it. It is minus 2 into cos 60, as you know, is a standard value. What's the value? It is 1 over 2 into cos A. Now, 2 and 2, they get cancelled, hence we get minus cos A, which is nothing but the right hand side. Okay. So, we started with even this could be expected for 2 mark question only, because one mark for expansion. We have used the formula cos A plus B and cos A minus B. We have done the expansion. Then those two terms, they get cancelled. Adding the remaining two terms using the allied angle rule, then you can get the numbers 2 and minus 1 by 2 get cancelled, and finally we will be left with minus cos A, which is the right hand side. Now let me move on to the next problem. Now in the next problem, here of course in this problem what I did just now, it is a direct application of the compound angle formula. You need not do anything, it's a direct application, straightforward problem. In the next problem, little bit thinking of is needed. Prove that tan A into tan of 3A into tan of 4A, tan of 4A should be equal to tan of 4A minus tan of 3A minus tan of A, minus tan of A. So the left hand side you observe, it contains a product of three tan ratios, tan of A into tan of 3A into tan of 4A. Right hand side, it's a difference here, tan 4A minus tan 3A, tan minus tan A. Usually, whenever we prove certain result, the common practice is to start from the left hand side and to arrive at the right hand side. This is a common practice. Sometimes we start from the right hand side also, show that it is equal to left hand side. In very rare problems, we simplify both LHS and RHS and arrive at a common result. But maximum problems we start from left hand side to right hand side. But in this one, if you start here, it's difficult to get the right hand side. I am not saying not possible, it is difficult to get the right hand side. Now let me look at the terms here. See, all the terms are containing only tan ratio. That shows that we have to use the tan compound angle formula, tan of A plus B or tan of A minus. That gives us one hint. Look at the number 1A, 3A, 4A. Clearly we see that 1A plus 3A is equal to 4A. So what I do is, I don't start from left hand side. Consider tan of 4A. Tan of 4A. Because that is the biggest number here, isn't it? 1A, 3A and 4A, that's the biggest. Tan of 4A. You can write it as 2A plus 2A also, but we are having number 1A and 3A. So let me write it as tan of 3A plus A. Now, the compound angle formula comes into picture at this stage. It was only one angle. I have split it into two parts here, sum of two angles. So I am using the formula tan of A plus B. What is tan of A plus B? It is tan A plus tan B divided by 1 minus tan A into tan B. So what was the left hand side? Left hand side was tan of 4A. So tan of 4A, I had split that as 3A plus 1A, and I have applied the formula tan of A plus B on the right hand side. Now left hand side I have kept it as it is. Next step is, see, there is one term here, it's a fraction on the right hand side. Let me cross multiply. Cross multiply means we have to, the left hand side, we are having only one term, and it has to be multiplied by the right denominator of the right hand side. So let me write it as, that is tan of 4A, that is the existing left hand side, into, right inside the bracket, 1 minus tan of 3A into tan of A, into tan of A. And write this right hand side as it is, the numerator of the right hand side, tan of 3A plus tan of A. Here tan of 4A means divided by 1. So 1 into this one and this into this term. So that's what I have done. Tan 4A into 1 minus tan of 3A into tan of A. The right hand side is tan of 3A plus tan of A. Now remove the brackets on the left hand side. Tan of 4A into 1, that is tan of 4A only. tan of 4a into tan of 3a into tan of a. Now right hand side, write it as it is, tan of 3a plus tan of a. Now look at the problem which I had given you. In the problem, we had a product on one side, tan a into tan 3a into tan 4a, that was equal to the difference of 2-3 terms there. Now what I do is, I take both the terms on the right hand side to the left hand side. Naturally, they change the sign. That is, tan of 4a, write as it is, take it to the left hand side, it becomes tan of minus tan of 3a, the other term becomes minus tan of a. Now shift the whole product to the right hand side, this is minus and automatically it becomes plus. So tan of 4a into tan of 3a into tan of a. You just look at the problem which I had given you. This is nothing but the same problem, but only the positions have changed. See, in the problem I had given you, show that tan a into tan 3a into tan 4a equal to this expression, tan 4a minus tan 3a minus tan a. So we have proved the result here. So instead of taking LHS or RHS here, looking at the numbers that have been given in the problem, we split the number, or to get the same answer, shift it to the left hand side. Therefore, you write it as tan of a into tan of 3a, because here a is equal to b, I am writing b is equal to a, that's all. Tan of 4a should be equal to tan of 4a minus tan of 3a minus tan of a. Now this is the required result. Therefore, in such problem, most of the problems I told you already, we start from the left hand side and arrive at the right hand side. That's common practice. In this problem, now see, in this problem I have taken the number 1, 3, 4. The same rule you have to follow, whatever may be the angle here. Usually it would be given. Suppose 5a is given. And in the problem, we will be having one angle 2a, the other angle 3a, like that. In that case, now write 5a as 2a plus 3a. Usually in such problems, it would be given as sum, so that you can write one number as the sum of the remaining two numbers. Here I have taken 1 and 3, it can be 8. 8 can be split as 3 and 5. 5 can be split as 2 and 3, like that. So depending upon what number is given in the problem, you have to think a little bit. Consider the compound angle formula of tangent and then expanding and cross multiplying, arranging the terms here, you get the required result. So only in this problem, we have to do a little bit thinking and try to solve the problem. Now, let me move on to the next problem. Each problem there will be slight difference. So you have to, when you work out more and more problems, naturally you will be familiar with the procedure of solving the problems. Now, in the next problem, now I am working out as a problem, but it can be taken as a formula. Wherever you need, you can use that as a formula. The problem is like this. Sine of a plus b into sine of a minus b. See, you have to prove this is equal to, it is having actually two results. First result can be sine square a minus sine square b. Either sine a plus b into sine a minus b will be equal to sine square a minus sine square b, or it would be equal to cos square b minus cos square a. See, in other branch of mathematics, sometimes we come across this one. Sin a plus b into sin a minus b can be taken as sin square a minus sin square b, or it can be cos square b minus cos square a. Usually we come across this one. This product is equal to the difference of these two terms, it would be there. So this can be given as a problem also, but whenever you have this product, you can write the result to be sin square a minus sin square b. Now first we start with the left hand side. One by one we try to get both the results. Now start from the left hand side. Now, sin A plus B into sin A minus B. Let me use the compound angle formula. What is sin A plus B? Sin A into cos B plus cos A into sin B. Close the bracket. Into you write sin of A minus B. The terms are same but the sign is different. Sin A cos B minus cos A sin B. Now look at the product here. We are having one term into another term. Sin A cos B plus cos A sin B. Sin A cos B minus cos A sin B. Now it is of the form, suppose I take it as x here. X plus y into x minus y. It is a basic algebraic formula which you learnt in your high school classes. X plus y into x minus y. What is that equal to? X square minus y square. Or you might have learnt it as a plus b into a minus b also. Even then it is a square minus b square. So I can use that algebraic formula, write it as a means first term, b means the second term. That is sin a into cos b the whole square minus cos A into sin B the whole square. Remember, I am using the formula A plus B into A minus B. So it is A square. A square means square of the first term. B square means square of the second term. Now, let me write it as sin A cos B whole square means both the terms should be raised to the power 2. That means that it is sin square A into cos square B. Minus, same thing here also, it is cos square A into sin square B. Now, this is what we get. So, when you apply the formula, compound angle formula, both of them, multiply, write the expansion. When you apply the algebraic formula and multiply them, we get these terms, sin square A cos square B minus cos square A sin square B. Now, there are two results that you have to prove. Look at the first result. It does not contain any cosine term at all. It contains sin square A and sin square B. That gives us a hint that this cos square B is not wanted, cos square A is not wanted. We don't want cosine terms, we want only sin term. So how to eliminate? Using the basic identity. You know that sin square theta plus cos square theta is equal to 1. Therefore, cos square B can be written as 1 minus sin square B. Similarly, cos square A can be written as 1 minus sin square A. So that both the cosine terms, they get eliminated. So this is sin square A into 1 minus sin square B. Minus here 1 minus sin square A into sin square B. Suppose in the problem they ask you to prove both the results here. In that case now you give a number for this step, particular step. If only one result is asked in the examination, then you need not do that one. Suppose the first result is asked, no, try to eliminate cos square term. Suppose the second result is asked, no, you eliminate the sin square terms, okay. But here, since I am proving both the results here, I am giving a number for that particular step. In this step, I have eliminated cos square A as well as cos square B. Therefore, this would be equal to, left hand side is equal to, do the multiplication. In other words, remove the bracket. Sin square A minus sin square A into sin square B. Then minus 1 into sin square B. Minus 1 into sin square B is minus sin square B. Minus of minus plus, it is sin square A into sin square B. Now look at the terms. Minus sin square A into sin square B plus sin square A into sin square B, they get cancelled. So what is remaining now? It is sin square A minus sin square B. So I got the first result here. Because both the results I am supposed to prove here, I got the first result. Now, that's what I told you. In the examination, they don't ask you both the results. Usually, either this would be asked or this would be asked if the problem is given. In that case, no, if the first result is asked, then you here don't give any number here. Directly you eliminate cos square b and cos square a. Suppose the second result is asked, not the first one. In that case, now in this step, you have to eliminate sine square a. How do you write? 1 minus cos square a. Sine square b, how do you eliminate? 1 minus cos square a. So that sine terms now will be eliminated. Now here, to get that result, I write in one put sine square a as 1 minus cos square a and sine square b as 1 minus cos square b. Since want to eliminate both the sine terms, so this would be equal to, go to the first result here, 1 minus cos square a into cos square b. Similarly, minus, write cos square a as it is, the other one 1 minus cos square b. So, that's why I have given a number there. So, in one, replace or put, you can write replace or put, both mean the same thing. Sine square b as 1 minus cos square b and sine square a as 1 minus cos square a. Now, remove the bracket. Be careful when you multiply. There are two terms inside the bracket. Both of them should be multiplied by the term outside the bracket. So 1 into cos square b, that becomes cos square b, minus cos square a into cos square b. Next, minus cos square a into 1. So that would be minus cos square a. Finally, minus of minus plus cos square a into cos square b. In this case also, you clearly observe that the product term, they get cancelled. One is positive, the other is negative. Now, cos square b minus cos square a. So, this was the second result that you are expected to prove that one. See, both of them are standard result. But in some problem, in the another branch of mathematics, you may get that product sin a plus b into sin a minus b could be written as sin square a minus sin square b. Or suppose you are having sin square a minus sin square b, it could be written as a product sin a plus b into sin of a minus b. Now the next problem is also of the same type, where instead of sine, I am having cos function. That is, to prove that cos a plus b into cos a minus b, here also we are having two different results, one after another we can try to prove. So prove this as cos of a plus b into cos of a minus b. Now here it has got two results. One result is cos square a minus sin square b, or it can be cos square b minus sin square a. You observe the difference here. See, in the previous problem, we had sin a plus b into sin a minus b. So, first answer was purely in terms of sin square a minus sin square b. The second answer was purely in terms of cosine term, that is cos square b minus cos square a. Here, both of them are containing both sine and cosine. First cosine function comes, then sine function comes. The procedure is same. We start with the left hand side, apply the compound angle formula, and then try to get the result one by one. Now start with the left hand side, write the expansion. The expansion being cos a plus b. Cos a cos b, here it is minus, plus, if there is plus, this would be minus. Sin a into sin b. Now the second expansion is cos a into cos b. When that is minus, here we will be having the positive sign. So it becomes sin a into sin b. Sin a into sin b. Now the same algebraic formula I am using here, that is, it is of the form a plus b, a minus b into a plus b. That is, using our high school algebraic formula, it becomes a minus b into a plus b would be a square minus b square. A square means cos A cos B the whole square minus sin A sin B the whole square. The whole square. Now here again raising the power to 2 for both the terms here, cos square A into cos square B minus sin square A into sin square B. So I have used the compound angle formula expansion and I have multiplied. I have used the algebraic formula. I have multiplied that one. Now these are the terms we are having. Now look at the first result. What does the first result say? It says that cos square, this would be equal to cos square A minus sin square B. See, look here, first term I am having cos square A, cos square B. And the answer I want cos square A, sin square B. This I want and this I want. I want to eliminate cos square B is not wanted, sin square A is also not wanted. Therefore, you have to eliminate. Again we go back to the identity. Cos square B can be written as 1 minus sin square B. Sin square A could be written as 1 minus cos square A, so that we will be left with whatever terms we needed in the first result. So let me write it as, keep that cos square A as it is into cos square B, write it as 1 minus sin square B. Close the bracket. Whenever two terms and the negative sign is there, always write inside the bracket. Minus sin square A, you write it as 1 minus cos square A and write sin square B as it is. So after getting this one, you have to look at the result. Whichever we need, you have to keep them as it is. Whichever you do not want in the final answer, you have to eliminate this one. We use the identity. Multiply. Cos square A into 1 is cos square A. Cos square A into sin square B with the negative sign. Cos square A into sin square B. Now here, always remember when there are two terms, both of them should be multiplied by the term which is outside with the sign here. That is why I always tell you to write the brackets when you are having two terms, more than one term, and we are having a minus sign. Minus 1 into sin square B, it is minus sin square B. Now minus of minus plus, it is cos square A into sin square B. Cos square A into sin square B. Again, this particular step here, I will give a number. Give it as 1 or 2, any some notation you give there. Now look at this one. Minus cos square A sin square B plus cos square A sin square B, they get cancelled. What is remaining now? Cos square A minus sin square B. And this is the answer that we wanted in the first step. I had given you two answers actually. So I got the first answer. So in the first answer, in both the answers we have cosine term first. Cos square of the first angle minus sin square of the second angle. Now we want to get the second result. What does the second result say? Cos square B minus sin square A. Always cos comes first. Cos square B minus sin square A. So we go back to this only. This is the base with the help of this one. Again, both the result will not be asked. Any one of them will be asked. Depending upon what has been asked, you have to, in this stage, in that case, no need not write the number 1 there. In that stage, we have to eliminate whichever we do not want in the final answer. Now, I want the answer cos square B minus sin square A. So this I want and this I want. I do not want this, I do not want that. How do you eliminate? Cos square A, you can write like this. First one, write one sentence. In one, put cos square A as 1 minus sin square A and sin square B as 1 minus cos square B. I am replacing these quantities which I want them to be eliminated. So this would be equal to 1 minus sin square A into, write the brackets, into cos square B. Then minus sin square A, you write it as it is, and here that sin square B could be written as 1 minus cos square b. Now it is the usual thing, multiplying, removing the brackets. Cos square b into 1 minus sin square a into cos square b. Then minus sin square a into 1 is minus sin square a, minus of minus plus, this is sin square a into cos square b. Always the product term, whatever term we will be getting, that gets cancelled. So this and this, they get cancelled. We are left with cos square b minus sin square a. Of course, all these four results in previous two problems I given, they can be remembered as formula also. Whenever you come across the product, you can write the right hand side. Suppose you have the right hand side, you can write the left hand side. But as a problem also you can expect that one, and as a formula also you can remember this one. So this completes the problem on the compound angles. In this chapter, the second chapter of trigonometry, we had to discuss compound angles, multiple angles, submultiple angle and transformation formula. I had mentioned about that in the introduction class. Now first part of it is over, that is compound angles we have completed. I have taught you the formula, and then using the formula we have evaluated, we have simplified, we have proved certain results. In the coming session, I am going to give you some formula for the multiple angle. Multiple angle means when an angle A is multiplied by an integer 2, 3, 4, 5, 7, 8 like that, we call it as a multiple angle. Now these formulas, sin A plus B, cos A plus B, the derivation is not for you. You have to by heart and work out the problem. But in the case of the multiple angle formula, the derivation is also given in the examination, either for a 2-mark question or a 3-mark question. So I will be taking them in the coming session, in the next session. Thank you.